So here we are going to learn what SOAP is and what SOAP is not, and we are going to learn the message structure, SOAP message structure. We are going to see fault message, and then we are going to see SOAP message exchange pattern a bit, and then we are going to learn SOAP with attachment. So what is and why? What is and what SOAP is and what SOAP is not. So this is the W3C definition of SOAP. SOAP is a lightweight protocol intended for exchanging structured information. We are talking about XML mostly in a decentralized and distributed environment. SOAP uses the XML technologies to define an extensible message framework. So to define extensible messaging framework, we are going to actually talk about the aspect of extensibility later on. Providing message construct that can be exchanged over a variety of underlying protocols. So SOAP is designed to exchange XML messages over different type of transport protocols, including HTTP. I would say 99.9% of the time we are talking about sending and receiving SOAP messages over HTTP, but it could be transported over different transport protocols such as SMTP or JMS, things like that. The framework has been designed to be independent of any particular programming model and other implementation-specific semantics. So again, this is the whole idea of using web services, which enables interoperability between parties who use a different programming language, different programming model, different operating system. So it provides loosely coupled communication, which enables interoperability. So what SOAP is? It stands for Simple Object Access Protocol. So as this protocol indicates, it is a protocol. It is a wire protocol in the similar sense to IIOP is on-the-wire protocol for COBRA, and JRMP is on-the-wire protocol for RMI, remote method invocation. Okay. So the difference between SOAP as a wire protocol from other wire protocols such as IIOP and JRMP is that XML is used for data encoding in SOAP. Okay, so in the case of IIOP and JRMP, it's binary protocol. Okay, while in SOAP, XML is the data encoding scheme, so text is actually being used. Okay, so what is a data encoding? Encoding actually specifies the rules of how types of data are being exchanged. Okay, so in the case of SOAP, the types of data are in the form of XML. Okay, so it is actually the difference between text-based protocol versus binary protocol, but they are all on-the-wire protocol, which means each of these on-the-wire protocol has to have encoding schemes. So just to give you a sense of what the encoding is all about, for any communicating partners to be able to communicate, they have to agree upon encoding schemes. So as I said before, encoding scheme specifies the rules of communicating. And one of the things that you have to actually agree upon is, for example, how to represent integer value. You could represent integer value in 1 byte, 2 bytes, 4 bytes, kind of things, right? So until communicating parties agree upon how they want to actually exchange integer value in a form of encoding scheme, they are not going to be able to communicate. So same deal with SOAP. SOAP, they actually decide the encoding schemes, and that encoding scheme is based on the XML. Okay. It also supports XML-based remote procedure call called the RPC. This is not supposed to be used anymore. The reason SOAP designers came up with RPC scheme is to ease the migration of existing RPC distribution schemes, meaning most of the applications, most of the distributed applications are written in a procedural model, meaning the sender, the caller is actually calling a method of in another machine, and that is called the RPC, remote procedure call. Okay, so the SOAP actually provides XML-based RPC to ease the migration of existing RPC-based application to the SOAP-based system. But these days, this RPC-based scheme should not be used. Instead, just sending XML data back and forth between client server is recommended. So later on, we are going to talk about document-driven model versus RPC, model. So it's actually is defined in the form of style in WSDL document. Okay, so that's something we're going to talk about later on. So these are basically what SOAP is all about. So do I need to know how SOAP works in detail as a Java developer? This might be the question that you might want to ask. The answer is yes or no. Okay, the yes in the sense that understanding it will help you to build a better application. Okay, just like a long time ago, before everyone is actually writing their distributed application on the higher level, they used to actually write application on the top of TCP/IP, like FTP and Telnet. These are primary examples of TCP/IP application. So you don't have to actually know how you don't have to know how things work on the TCP/IP protocol level, but sometimes in order to debug your socket, TCP/IP socket-based application, you have to actually understand how TCP/IP works. Okay, so that is the same reason you might want to actually understand why how SOAP works to be a better developer in a sense. Okay, another reason you might in fact actually have to deal with SOAP is you might in fact have a message handler. This is like a filter that you can actually plug in, and what it means is that it will read a SOAP message, and in that case you have to actually understand the structure of the SOAP message in order to read. Okay, now the last reason is when you're trying to send SOAP messages over JMS. JMS at this point does not provide, at least this is the case several years ago. I'm not sure they now support the SOAP-based as message type. I don't think they do. If you want to use a JMS as a transport instead of HTTP, then you have to create the SOAP message yourself and actually send it as a text message. Okay, so in that case, you have to really know how the SOAP message is supposed to be constructed. Okay. Okay, so that is the yes part. Now the no part is that typically you are going to use higher level APIs such as JAX Web Services to build web services server and client application. So in this case, JAX Web Services library is responsible for creating SOAP message underneath. Okay, so in that case, you as a developer is insulated from how SOAP works. SOAP just happened to be one of those communication protocol. Okay. So you're dealing with the high-level APIs, which is provided through JAX Web Services, and so that's actually the reason you might not need to know how SOAP works underneath. Okay, so in the case, yeah. So basically, in this case, how SOAP works is hidden from developers. All right. So with that said, let's talk about how SOAP works. Okay, so here we are trying to understand SOAP. SOAP characteristics: it is stateless. It doesn't contain any state information. Okay. If you want to pass the state information, that has to be provided as part of the application data. So SOAP protocol itself doesn't say anything about the state. Okay. It's a one-way message exchange paradigm. So if you want to have a different, let's say, exchange paradigm, such as request response or request multiple responses, then again it is the responsibility of the application, or you can just depend on transport. So for example, you can take advantage of HTTP protocol, which is by nature request and response model. Okay. So if you're sending SOAP message over HTTP request, that means that is a SOAP request message, and if you're actually getting a SOAP message over HTTP response, then that is considered as a SOAP response message. Okay, so either you have to actually depend on some transport protocol like HTTP, or you could actually have application level the exchange patterns. Okay, you might in fact have some kind of indication this is a response message on some level, application level, and things like that. Or the third choice is using high level standards such as WS addressing. So this is something we are going to cover on day 4 or 5. And WS addressing is providing addressing information, the transport neutral addressing information. Okay, so you could actually take advantage of WS addressing to have some kind of interaction patterns built on the top of a SOAP. But SOAP itself is very simple one-way message exchange paradigm. Okay, and SOAP is silent on the semantics of any application-specific data it conveys. Yes, this is kind of obvious. SOAP does not get involved. This is a protocol. It doesn't care what kind of data is being transported. Okay, so what SOAP is not? So SOAP is not a component model. So it is a protocol and it's not a component model. So it will not replace object and components such as EJB and Java Beans. Okay, SOAP is not a programming language. So it will not replace Java or .NET and things like that. So or C# or C++. In fact, you need some kind of programming language to build the SOAP message if you want to, or read SOAP messages. It's not a solution for all. So the SOAP is a very simple communication protocol compared to other sophisticated communication protocols such as RMI or CORBA. Okay, so it will not replace other distributed computing technologies such as RMI or CORBA. CORBA is actually long gone, so it's actually probably the moot point. Okay, so design goals of SOAP. So as its name implies, it's a simple object access protocol. So, as its name implies, one of the primary design goals is simplicity. So it's very simple, as you are going to learn in a few minutes. And another important aspect of SOAP is that extensibility. Okay, so new standards will actually define the how message is supposed to be exchanged with new features. For example, security and transaction maybe, or state management and things like that. So all those high-level features or functionality could be built on the top of SOAP. So SOAP is designed with extensibility in mind. Okay. And as I said before in previous slides, SOAP is designed very simple, so it doesn't support advanced distributed computing features such as distributed garbage collection or object by reference or activation or message batching. So these are advanced the distributed computing technologies that are supported, for example, by RMI. But SOAP is not designed to support these things because it really complicates things. Okay, so moving forward, SOAP message structure. So this is a SOAP message structure. So on the left, you have SOAP message with attachment. So you could have 0 or more attachment, and then you have a primary MIME part. Okay, so this primary MIME part now could be considered as SOAP envelope. So SOAP envelope contains header part and body part. And each header part, there is only one header and there are only one body in SOAP envelope. Okay, and SOAP header part, you could have a multiple header entries, okay, or header blocks. The same terminology. In SOAP body, you could have the body entry, body entries, okay, and or body blocks. So let's talk about these things in a bit more detail. So message envelope representing this whole thing. So you might actually have namespace information and encoding information at the top, and then it will have header and body. By the way, header is optional. Okay, so you don't have to have a header part. Okay, this header part contains header blocks that could be consumed by intermediary nodes or ultimate receiver node. Okay. These days, SOAP messaging is still done between 2 points, but SOAP messaging could be done through, through multiple intermediary nodes between the sender and receiver of the message. Okay, so the intermediaries can actually read SOAP headers, and they can actually do whatever they want. Okay, all right. Now, body part is mandatory, so you have to have a body part. If you don't have a body part in your SOAP message, that's an invalid SOAP message. And this body part is handled only by ultimate receiver, so body part cannot be read by intermediary nodes. Okay. So again, as I said, most of the SOAP communication is between 2 points, meaning sender and ultimate receiver. So intermediaries are not that much involved. Okay. In most real-life environment. Okay, so SOAP header. So this is actually prefix, and this is the name of the element. Okay, so SOAP header is used for high-level functionality extension, for example, context management or state management, authentication, authorization, transaction management, many high-level semantics. Okay. And SOAP header is made of, again, header blocks or header entries. And so, most web services, SOAP-based web services standard activities are basically defining standard header entries for particular domain like a security. So there is a web services security specification which defines what kind of headers are supposed to be included in SOAP header structure for supporting, for example, authentication and authorization and integrity of the message and things like that. Okay, so so that is the SOAP header, and as I said, SOAP header is made of multiple header blocks or header entries. So header entries is a child element of SOAP header, which we just have seen in previous slide. And again, it's designed in anticipation of various uses for SOAP by SOAP intermediaries, and can be individually targeted as SOAP nodes and allow SOAP intermediaries to provide value-added services. So if you want to send, it's possible that the sender send a message, and then that message is going to be received by the first intermediary node. That intermediary node will take a look at one of the header blocks, and then it will do whatever it has to do. It might actually perform some logging, or it might perform some authentication and things like that. So these header blocks are consumed by intermediary nodes as well as the ultimate receiver. So header blocks might actually contain some high-level semantic information such as security information and things like that. So may be inspected, inserted, or deleted or forwarded by SOAP nodes encountered along the SOAP message path. Okay, so SOAP nodes encountered along the SOAP message path includes intermediary nodes as well as ultimate receiver node. Okay, so that is a SOAP header. Now let's talk about SOAP body, and it's represented by prefix of env and then body element. It's made of body entries or body blocks, and it is supposed to be consumed only by ultimate SOAP receiver. Okay, and it contains end-to-end information. Okay, so if it is a document style communication, then it should contain application data in the form of XML. If it is the RPC style, then it will contain RPC method and the parameters. Okay, and it also could contain SOAP fault message. Okay, that is actually being sent from the service provider to the client if there has been a problem. Okay, so fault message. So if there is a problem in the server, well, if the server actually encounters a problem, then it will send a fault message to the client. So that is actually captured in SOAP fault, SOAP fault element, and that is represented by fault element. Okay, so it carries error or status information. And on the fault element, it could actually contain 4 sub-elements: fault code, fault string, fault actor, and detail. Now, SOAP specification has defined fault code values. So these are predefined by SOAP specification, like a version mismatch. So version mismatch happens when SOAP 1.1 is communicating with SOAP 1.2 server. Okay, so SOAP 1.2 server at that point have 2 options. One option is sending back fault code with a version mismatch, indicating you are actually dealing with the wrong version. Okay, so so that is one possibility. Another possibility is to handle SOAP 1.1 request with SOAP 1.1 response. Okay, so that's another response. So SOAP 1.2 the server can do. The other direction, if SOAP 1.2 client is communicating with the SOAP 1.1 server, then SOAP 1.1 server definitely will send back version mismatch because it cannot handle SOAP 1.2, right? Okay. Alright, the next fault code is the must understand. Okay, what it means is that receiver mode, receiver can, so this fault code gets returned when the server doesn't understand the SOAP header block, and or if we cannot handle the SOAP header block. By the way, the SOAP header block that is coming from the client should have a must understand flag set to true. Yeah, what it means is this: when the client send a header block with this must understand flag set to true, what that means is that client wants to make sure the server responds back with must understand error code if the server cannot handle it. Okay, the reason is because client wants to receive some kind of indication if the server cannot handle it, so that it can take it can actually take a next option. Okay, which means the client does not want the server just ignores its request. Okay, in that case, client doesn't know what to do with it, right? It doesn't receive any response, and so it cannot take any the fallback option. Okay, so in that case, client actually send must understand flag true, and if the server cannot handle it, then the server has to send back this must understand fault code so that client can take a fallback option. This client fault code means that there is actually an error in the request message, like SOAP message is not valid, or SOAP message is not well formed, or something like that. The server fault code means that there has been a problem on the server side. Maybe server doesn't have enough memories to handle it, or something like that. Okay. So this is an example of fault example. So this is the request message. So request message, you can see this is a SOAP envelope, okay, and this is the namespace. This is a SOAP envelope, SOAP namespace, and that. Oops, sorry. This is the SOAP namespace, and prefix is env. So it actually is using env namespaces. So envelope, header, body, these are all belong to SOAP. SOAP specification. So these are the elements defined in SOAP. Okay, and so in this, this is made of header part and body part. Now in the header, it does have two header blocks. Okay, so it does have extension 1 and extension 2, and then it says the must understand equals 1 and must understand equals 1. Okay, so if the server does not understand these header blocks, it doesn't know what do you mean by extension 1? I don't understand it. Okay, in that case, the server send back this response message with a fault code. So this is inside the body. This is a fault message. So it does contain fault code it must understand, and this is the fault string. So fault string is basically humanly readable description of the fault. Okay, and inside the header, it also actually gives you information of what caused the fault. Okay. Okay, so SOAP 1.1 namespace URI. So these are the namespaces that are already defined by SOAP specification. Okay. Now, in terms of version mismatch, this URI value, this namespace is used as a version. So this one is SOAP 1.1. Okay, and there is SOAP 1.2 namespace, which is w3c.org/2000, I believe 3. Okay, so that's how the SOAP server actually knows what is the version of that request message. Okay, same thing for the client. Client will actually know what is the response message's version. Okay, it will take a look at this namespace. So this namespace is used to indicate version 1.1 and 1.2. So 1.1 is using 2001, and 1.2 I believe is 2003 or something like that. Okay, so this is the SOAP namespace example. So we learned yesterday about the namespaces, right? So this is again complete SOAP message, SOAP envelope. In this case, we don't have any header, and that's okay because header is optional. and here we have env namespace. So any elements that belongs to this namespace is supposed to be prefixed with env. Okay, so this is a convention. env is a convention, but you don't have to use env. You can use xyz if you want to. So you have a body, and then we have our own namespace defined here. So here we have defined our own namespace, application specific namespace, and we are going to use m as a prefix. Okay, so in this case I should have m here, get last price twice, and I also should have, yeah, on the symbol I should have in this case m as well. So that is actually my mistake. Okay, so let me just make sure slide number 22 need to be fixed. Okay, so I should have m over here as well, and over here as well as on symbol, because that symbol belongs to this namespace. Okay, and we don't even have a default namespace. Okay, so that's the reason. It cannot have any prefix. I mean, meaning it cannot. It should have a prefix of m. Okay, so it's right now 12:30. So let's have 30 minutes lunchtime break, and we'll continue when we are back. Okay. All right. So let's move on to the next SOAP message exchange. So SOAP provides a one-way message exchange. Well, it's not exchange, it's actually, the one-way message sending model. So SOAP is a simple messaging framework for transferring information specified in the form of XML info set between initial SOAP sender and ultimate SOAP receiver, between sender and the receiver. Okay. The more interesting scenarios typically involve multiple message exchanges between the two nodes, request and response pattern. Okay. Now, as far as the XML info set is concerned, you can think of it just XML. Okay. Okay. So there are few the patterns that are typical in the SOAP message exchange. So conversational message exchange is used to exchange XML documents. Can be multiple message exchange patterns. Okay, so they can send, the sender can actually send the multiple messages, and responder, in this case service provider, will actually send back the response messages in the form of XML, or it could be in the form of request remote procedure call. So used when there is a need to model certain programmatic behavior. So in this case, the XML message should contain the name of the procedure call and the set of parameter values. Okay, SOAP with attachment. So SOAP 1.1 with attachment is another specification. It's a separate specification from SOAP 1.1, and it actually uses the MIME multi-part related as a container. So this is exactly the same. Multi-part related header, multi-part related container that your email application uses. Okay, so SOAP message could be the SOAP envelope, and then arbitrary number of attachments, 0 or more attachments. Okay. So SOAP envelope and payload can reference attachments and relative URL in the SOAP envelope. So these attachments are going to be referenced. Okay, so that is the end of the presentation. Now, the next, the hands-on lab for this one is we are going to in fact build our first JAX Web Services, the Hello World Web Services server and provider. Okay, and we are going to in fact the observe SOAP message between the client and server. Okay, so even though we haven't really talked about JAX Web Services with annotation and all that stuff, but we'll try to build it, and documentation is very detailed. So the documentation is called JAX Web Services _ Hello World. Okay, so open that lab documentation. Right, so I'm gonna actually wait for you guys to open the documentation of WS JAX Web Services Hello World. Okay, and here we are going to create Hello World Web Services. Okay, so that's what we are going to do in exercise 1. Okay, let me actually see what. So let me actually explain exercise 1. So here we are going to build this Hello World web service application step by step. Okay. So first you are going to build a new project. Okay. So let's try to follow these steps. Okay. New project, and you're going to build the web application. Okay. So select Java Web and Web Application. Okay. So select web application, and then we are going to name that application as Hello Web Service. Okay, so go to oops, not this one, back. I want web application, and next, and I'm going to name it as Hello World Web Service. Okay, and I am going to I'm going to actually have it more. I'm going to actually have it my left so that I can access the application easily if I want to. Okay. Alright, so basically we just provide the project name, and then we are going to select the server and so for the sake of this exercise we are going to choose Java EE5. Okay. And as far as the server is concerned, you are going to use whatever server of your choice, but we are going to use Java EE5 because Java EE5 is the first version that actually supports the web services. I'm sorry, Java EE4 is actually the first one that supports web services, but we are going to use Java EE5. Okay, and click next. And here we are not going to use any web frameworks, so you can say finish. So here we are basically building a web application. That's all. So we have Hello Web Service web application with maybe index.jsp page. Okay. All right. Okay. Now we are going to create a Java class called the Hello Java, and we are going to expose this Java class as a web service. Okay. So try to create the Java class, and then we are going to name as hello, and we are going to actually have it on the my package. Okay, so let's create Java class, and hello, and the name of the package is my package. Okay, so that's what we just did, and click finish. So we have created the hello class. Now we are going to add a business logic called say hello. Okay, so I'm going to just copy this guy. It's a very simple say hello method. Okay. Alright, so say hello method, and it will receive name from the client, and then it will respond back with hello and exclamation mark. Okay, now this is it's just a regular Pojo class. Now we want to make this Pojo class to be web service. So here what you're going to do is you are going to use annotation web service. So here you can actually control P, and you can select web service, and we're going to just use web service like this. What it means is that I want to expose every method in this class to be exposed as web service annotation. Okay, if you just type it, then this is not going to be automatically imported. Okay, so code completion, when you do code completion, it does the import, but if you're not doing it, if you're not doing the code completion, meaning if you just type in, then you have to actually import the other class. Okay, so you can just right click it and then fix imports, Control Shift I. Okay, alright, so basically what it means is we are exposing this class as a web service with a multiple well, in this case a single operation called the say hello. Okay, so you have to make sure that class is imported. Okay, now this is it. This is all you have to do to make this guy as a web services the provider. Okay, so what we are going to do is we are going to run it. Okay, you can run it or you can deploy it, and then we are going to test it. Okay, so It's starting a Glassfish server 4. Then we are going to we are going to test it. As you can see, as soon as you add this web service annotation, once this is compiled, NetBeans know that this is the web service provider, so it actually added these web services, the node. Okay. So let's wait. This is up and running. And then on the web services, you can right-click Test Web Service. So in this case, it's going to play the role of the client to the service, web service we just deployed. Okay. Okay, so I assume this is okay, good. So it's now deployed. Okay, so now we should be able to go this web service, and then we can right click this hello, then we can say test web service, and it will give me this the URI. So here I can type something. So I'm going to say JPassion. Then it will send SOAP request. So you can see it send the SOAP request that contains JPassion, and you can see this is the SOAP message. It has the header. It doesn't have any headers. It's just to have the header entries, and then it has a single body that contains a message called the JPassion, and this is a response message. Response message says hello JPassion. Okay. Alright, so we built and deployed and tested a web service. Okay, very simple, right? So this is what we did. Okay, now if you want to, so you have seen this SOAP request message and response message. Okay, and you can take a look at the WSDL as well. So this is something that we are going to learn later on. So this WSDL document represents the contract between service provider and service client. Okay, so in fact the client, the test client, will get this WSDL, and then you know, should be able to figure out what message is supposed to be sent, okay, and what message is supposed to be received. Okay, so that is WSDL. Okay, and then we are going to now build a standalone Java SE application that will actually play the role of the client. Okay, so we are going to create a Java application. So let's try to create a new project and Java application, and we are going to name it as Hello Web Service Client. You can name it in any way you want, but just to be consistent with the documentation, I'm just following. Okay. Alright, so that's pretty much all I have to do, and you know, the finish. Okay, so it will have the Hello Web Service Client with the main method. Okay, so now I want to create Web Service Client. Okay, so here what you do is you right click it, and then you select New and Web Service Client. What it means is, again, this is something we have not talked about yet in detail, but we are going to talk about this one multiple times moving forward. Basically, I want to access the WSDL document, Web Services Description Language document, and then I'm going to use it to find out what message is supposed to be sent to the server. Okay, so here we are going to right click the client and New and Web Service Client. Okay, now you can provide WSDL document in several ways. Okay, so you can provide the project, server project, or you can provide it from a local file system, or you can provide with, you know, the URL of the WSDL. So that's something that we already have it here. Okay, so this is the WSDL document that could be accessible through the web, in this case through the net. So I'm going to just copy this URL and then provide right here. Okay, and then finish. So what we'll do, and also let's see whether we want to actually provide the package. Yeah, you can provide a package. You don't have to provide a package. So I'm going to just follow the documentation and finish. What it means is that now I want the client to access this WSDL document and then generate some Java library that captures the API that accesses this web service through this the WSDL. Okay. All right, so we finish. Okay, and you are going to see now there will be web services reference node. Okay, so this is representing the client. Okay, so if you see web service client web services references, you can see we have the hello service, and hello port, and say hello. Okay. This is actually representing the web services operation. Again, this is constructed from WSDL document that it has downloaded. Okay. Now, what you want to do is, you can just write code here, but the NetBeans allows us to use this say hello. So you can just drag and drop like here, and it will actually create some template code like this. Okay, and so yeah, so this is actually pretty low level, so we can actually replace it. Okay, so what we are going to do is yeah, this has been changed a little bit. Yeah, so this is a pretty low level. So what I'm going to do is I'm going to just copy code. Okay, so we are going to actually talk about that API. That is pretty low level. The high level thing is actually I want you to just copy this code. It used to be creating this code. Maybe there is a kind of configuration flag or something like that. Oops. I want to replace the whole thing with the main. Okay. So what it does is that I have a main method, okay, which calls say hello, and say hello is actually the static class, a static method. Inside, I can actually access this my package and hello service. So this is actually created for me from WSDL. Okay, so I have a hello service object, and then I'm going to get the port object. This is a proxy that representing remote service. Okay. And then I can call say hello. Okay, so for now, don't worry about this code. It's just then let's actually try to run it. Okay, so as you can see, the result is displayed hello Sang-Shin. Okay, so we just created Java SE application. Okay, and then exercise 2. Now we want to capture the traffic, SOAP traffic. Okay, so there are two options. One is a TCP monitor, and the other one is WS monitor. Okay, so here let's try to use a TCP mon. So TCP mon is provided under this hands-on lab. Okay, so the way you are going to run the TCP mon is you go to the TCP mon directory. So I'm gonna actually go to, I have this one under the hands-on lab. So hands-on lab is my labs, and this one is hello world. So I'm gonna go to this hands-on lab, WS hello world, and then go to, then you'll see TCP mon. So go to TCP mon. Okay, then you see this TCP mon jar file, right? So all you have to do is just run that jar file. So you say java jar TCP mon jar. Okay, so now it's going to ask you let me just close this guy. So basically, what is the local port you want to use, and what is the server port? Okay, the server port 8080, so that's where the server application is deployed. So that should be 8080. The local port is 4040, so you want to change it to 4040. Okay, this local port is basically how this TCP-mon or later on WS monitor works is that they play the role of what is called the man in the middle. So this guy is waiting for a port, waiting for a request message on a port, in this case port 4040. So the client has to send request message to 4040 now, so that this message, request message, can be captured by this man in the middle, in this case TCP-mon, and then TCP-mon will receive the message and it do whatever it has to do, in this case logging it, and then it will send it to the final destination, to port 4040. When you receive the response message from the service provider, it will capture it and it will send the request message. So that's the reason you have to actually set the local port 4040, and then later on you have to change the client code to send the message to port 4040 instead of 8080. So that is something coming up. Okay, so you're going to actually add a monitor. So now it actually monitors any message coming to port 4040. Okay, so all right, so this is what you get. Now we have to change code in the client so that instead of sending the message to port 4040, we want to change it to the destination port 40. Instead of sending it to 8080, we need to change it to 4040. So the way you can do is that you can actually have a binding provider object, and then you're basically setting the end address property with 4040. Okay, so don't worry about this code for now. Let's just copy this code, and we are going to change the client code. Okay, so here we want to change the port number to 4040. Having a problem pronouncing it, and you have to actually import this class. So I'm going to just import it. Right click, fix imports. Okay, so now client is going to send the request message to 4040 so that the TCP monitor will capture the request message and then it will forward to the final destination. Okay, alright, so now let's try to run this code. So we're going to actually run it. So you can do this one, like this one. So yeah, it received the message correctly, and it is done through the monitor, TCP monitor. Now you can actually see it has captured the message. So you can see in this case it sent the sanction, and then it it's basically received the hello sanction message. Okay, all right. Okay, so this is the TCP-mon. The problem of TCP-mon is that it doesn't really actually indent. It doesn't perform the indentation of your XML documents. So it's very hard to read this. So that's the reason I don't use TCP-mon. Instead, we are going to use WS Monitor. So WS Monitor is also provided under under WS Monitor. Before you use WS Monitor, make sure you have a Java home environment variable set. So just to make sure the Java home was set, you can just say echo, and on Windows you can say Java home. Okay, so it is set correctly. Okay, so now what we can do is we go to WS Monitor directory, and then we're going to actually run this WS Monitor code. Okay, so here. Okay, so I want to go to. Okay, so here I'm going to go to WS Monitor directory, and then I'm going to run the WS Monitor. Just copy this code and run it, and now we are going to have a WS Monitor up and running. Now we're going to actually run the same client from here, so we're going to actually run it again. Okay, so it should actually have the same hello sanction to be displayed, right? Now you can actually capture this traffic. This is HTTP header. Now if you click SOAP, you can see it's capturing the SOAP message in a more pleasant fashion. The indentation is done for you. So you can see it actually sent the sanction message, and then it received the hello sanction. Okay, so that's basically what we have done right here. Okay, and exercise 4 is that you can actually perform context-sensitive Java documentation, but this is something that we are going to learn in detail later on. Okay, but just to follow this exercise, if you go to this Hello Java, and you can take a look at the Java documentation. Okay, so it will show you web services, annotation, documentation. Again, but don't worry about it. We haven't really learned this web service annotation at this point. The goal of this exercise is to see the SOAP messages using WS Monitor. Okay, so I'm going to give you guys enough time to do this because you have to actually go through step by step and everything. So I'm going to give you about 25 minutes. Okay, so we are going to, I'm going to give you 25 minutes. So right now is 25, and we will be back at 50, 150. And of course, I'm around, so you guys can ask questions. Okay, so let's